Wow, okay. Hey, welcome to lesson 2.3, the slopes of parallel and perpendicular lines. All right, these two types of lines have a special relationship, and we're about to go into it. So, before we begin, we should probably define what's a parallel line, what's a perpendicular line. This is a little bit of review from the beginning of our class, but it never hurts to review. So, what are parallel lines? Parallel lines are lines that never intersect. Okay, they never, ever, 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 ever intersect. They go on forever and ever and ever, and they will never touch. Just like you see over here. This could go straight this way, this could go straight this way. You know, they're not touching anytime soon. Now, if you look over here, this is perpendicular lines, and these are lines that intersect at a 90-degree angle. 90-degree angle, okay? Very specific. They can't be 89 degrees, they can't be 91 degrees. Perpendicular lines intersect to make 90-degree angles. So if you look here, that is a 90-degree angle, so these are perpendicular lines, okay? And a good piece of trivia, that's also called a right angle. And then you have this thing called skew lines. And skew lines are lines that intersect, okay? But at an angle that is not 90 degrees, okay? So any other lines that intersect, but they're not 90, are called skew. Or you could call that neither parallel or perpendicular. So that is it. So this would be like 102 degrees, okay? That would be a skew angle. So that's the vocabulary we're going to be using today. If you got that down, we're good to go. So if you look over here, we have two parallel lines, right? And I just want to take a look at their slopes. Let's look at the slopes, and I think we're going to find a good conclusion here, like a very interesting one. Well, not very, but somewhat interesting conclusion. So let's look at these two slopes, the slope of NP and LM. So the slope of NP is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and it's over 1, 2, 3, 4. So we got 11 over 4. All right? That's our slope of NP. Now let's look at the slope of LM, okay? Slope of LM is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4. Well, look at that. It's also 11 over 4. Now, doesn't that make sense? If these guys are never going to touch, they should probably have the same exact slopes, right? Because if they had different slopes, it's sooner or later they're going to come and intersect each other. But just like, rail lines, since they have the same exact direction at all times, they will never ever touch. So parallel lines have the same slope. Always. Doesn't matter where they are. This parallel lines will always have the same slope. All right? Big conclusion here. That is huge. That's my Donald Trump impression. Huge. So let's do the same thing with a pair of perpendicular lines. Let's find these slopes and see if we can get to an interesting conclusion. Okay? So we got NP over here, which has points over here and over here. Let's count it out. So we go down 1, 2, 3, 4, 5, 6. And then over 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go down 6, go over 9. Since it goes down, it's negative 6 over 9. You know what? Let's get into the good habit of reducing, so that's negative 2/3. So that's our slope here of NP. Let's look at QR. Okay? So we have a point here, we have a point here. Well, we go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then over 1, 2, 3, 4, 5, 6. So this time we go up 9 and over 6. So this one's positive, right? Because if one's going down, the other one should be going up in a perpendicular line. And our numbers switched around. It's up 9 over 6. So our slope here is positive 3 over 2. Interesting. So if you notice here, we have the same numbers, except one's negative and one's positive because one's going down and one's going up. All right, so one's always going to be negative. And they flipped over. So if this one's going down 6 over 9, this one's going to go up 6 over 9. I mean, sorry, that's not right. If it goes down 6 over 9, it's going to go up 9 over 6. So if you look here, basically the simple way to say it is one's positive and one's negative, and they flipped over. The math way to say that is to say they are opposite reciprocals, okay? Perpendicular lines always have opposite reciprocal slopes. Reciprocal slopes. All right? So you just flip it over and make it negative or change the sign. That's it. Parallel lines, perpendicular lines, always opposite reciprocals. All right, cruising along. So let's practice that out a little, okay? We're going to say if these slopes are parallel, perpendicular, or neither. We're just going to look at both of them, okay? So if our first slope is 5 and the other one's negative 1 over 5, are these parallel, perpendicular, or neither? Well, a little trick that you should do is that if you ever have a whole number, drop a 1 underneath it. All right, that will make things much easier. Okay? Always for whole numbers. Drop a 1 under it. Drop a 1. Drop a 1. That's what I like to say. So if you look at these two, did they flip over? Yep, that's 5 over 1, that's 1 over 5. And is one positive and one's negative? Yes, so these would be perpendicular. All right? Remember, one has to be positive, one has to be negative. If they're both positive, well, that doesn't make sense because, one has to be going down, one has to be going up. Okay? So that is perpendicular, and that is the perpendicular symbol. Now, if you look over here, slope 1 is 2/3, slope 2 is 2/3. They are exactly the same, and since they are exactly the same, these would be parallel. Rockin'. And then finally, we have our two slopes over here. The slope 1 is 4/3, slope 2 is 3/4. Now, the number one mistake I've seen while teaching math is that people will say that this is perpendicular, but it is not. Because as I've said, even though they're reciprocals, they are flipped over. One's not negative. One has to be negatives, okay? It has to be opposite reciprocals. There's two important parts there. So this is skew, okay? They intersect, but not at 90 degrees. All right, if you're with me, let's just do two more problems. Okay, so we're going to determine if these two slope lines are parallel, perpendicular, or neither. So now we have equations, all right? And to determine if they're parallel, perpendicular, or neither, we don't care about anything else. The only thing we care about is the slope, right? Nothing else matters. That's how we determine if things are parallel, perpendicular, or neither. So we're just going to circle the slopes. The slope here is 1/3, okay? And the slope here is 1/3. Well, if you look at these two, now we're just going to look at these two slopes. We're doing exactly what we just did here. We can ignore the rest of the equation. We don't care about that. We just care about the slope. Since they have the same slope, we know that these are parallel. All right? And a good way to figure that out to see if you got it right is just to check by graphing. All right? So I would like you to graph it on your own and see if this is correct. All right? Take a second, graph it, and then we'll come back in a minute. All right, if you did it correctly, you should have gotten two lines that look like this, and they do look parallel. All right, let's keep rocking. For our final problem, we have the lines represented by the equations 4x plus 6y equals 6 and y equals negative 3x minus 4. Are these parallel, perpendicular, or neither? Well, this is an interesting problem. So let's start by just writing down our equations, okay? Let's just start by writing these down. All right, we got 4x plus 6y equals 6, and we got y equals negative 3/2 minus 4. Now, like I said, all you need to find is the slope, right? But as we've learned in previous lessons, for this one, we can't find the slope yet, right? Because it's not in y equals mx plus b form. Only this one is. Oh, forgot my x. So here we know the slope is 3/2. This one, we have no idea. So what do we have to do? Hopefully you've thought this in your head. We have to find the slope by solving for y. So let's do that. So as I always say, to solve for y, circle your y, draw a line down, and we're going to have to move the 4x to the other side. All right, that's going to the other side here. When we do that, that cancels out. We get 6y is equal to negative 4x plus 6. Divide everything by 6. Okay, and we get y equals negative 4/6x plus 1. Now this fraction, negative 4/6, can be reduced. So we're not done yet. Let's reduce that. All right, negative 4/6 can be reduced to y equals negative 2/3 x plus 1. And now we have the slope. So let's circle this guy. Our slope 1 is negative 3/2. Our slope 2 is negative 2/3. Are these parallel, perpendicular, or neither? Well, you should know by now that since they are reciprocals, all right, it's a good indicator that they're perpendicular, but they're both negative. So actually, we don't know. All right, so this would say that they're skew. They are not perpendicular. They are both negative. They have to be opposites, and that's it. All right, guys, I gotta go. But remember, don't spit on a bird.